Alright, so here's our first question. It says, so that the gravitational field strength of Earth is 9.81 meters per second squared. So before we approach this one, we first need to recognize that we're not solving for force, we're solving for gravity. So we have two equations for gravity. We have mg, or force of gravity, mg, and gmm over r squared. So what we need to recognize is when we write down Fg is equal to mg, and Fg is equal to gmm over r squared, this little g is equal to this gm over r squared. It's the same thing. So if we actually equate the two equations together, we see that the little m's cancel out. So you can see that the acceleration due to gravity, or the gravitational field strength of some object, like for example, Earth, right here, is equal to gm over r squared. So I just take my equation, g is equal to gm over r squared, and plug in my value, so 6.67 times 10 to the negative 11 Newton meter squared per kilogram squared. And the mass of Earth, 5.972 times 10 to the 24 kilograms. And we're going to divide that by the radius. So to be careful again with this one, our SI units is meters, not kilometers. So I'm going to go 6371, and there's 1,000 meters per kilometer. So add 3 zeros, and we're going to square that because in the equation it's squared. Again, I'd pause this video right now. Make sure you can plug in yourself. What people usually have difficulty with in this topic is not necessarily the concept behind it. It's just it's kind of you guys are learning how to use more complex numbers, bigger, very big numbers, very small numbers, and can we plug it into your calculator correctly? So pause it, try it yourself, and then if you get 9.81 meters per second squared, great job. If not, try again. And you might have to ask how to use your calculator or maybe Google how to. There's different ways, but you need to be able to use that calculating device. So here's our next question. It says an asteroid has a mass of 5.1 times 10 to the 19 kilograms and a radius of 7.2 times 10 to the 4 meters. If your weight on the asteroid is 45 newtons, what is your mass? So we're going to start with our equation. Fg is equal to gmm over r squared. This time we're trying to solve for our mass. So we want to solve for our mass. So you're going to rearrange this equation. M is equal to, so you're going to multiply both sides by r squared. So we have Fg. We're going to multiply both sides by r squared. We're going to divide by gm, and this is our new derived equation. Okay. M is equal to Fg, r squared, over gm. So M is equal to, this is our force, it's 45 newtons. The radius of this asteroid, so we're on some asteroid, it's a lot smaller than Earth. We're standing on it, it's still pretty big. 7.2 times 10 to the 4 meters. We're going to square that. G, that's 6.67 times 10 to the negative 11 Newton meter squared per kilogram squared. And the mass of this thing is 5.1 times 10 to the 19 kilograms. Plug it all in, you end up with a mass of 69 kilograms.